Let's look at how we would do a Thevenin's equivalent on something like this, a bridge circuit. Okay, so let's just tackle it. So we would first remove the load resistor, which is typically across the center A to B in the circuit, and then redraw to find Thevenin. So we've stretched everything out so that we can see the series and parallel relationship. Thevenin then will equal the voltage from point A to point B. Okay, and so the equivalent values would be R2 divided by R1 plus R2 times the source, and then R4 divided by R3 plus R4 divided by the source. That will give us the Thevenin. Then, if we replace the source with the short, note the red lines represent the line electrical point as the red lines in part E. Okay, so if we move things around, I just redrew it here. So we redraw to find our Thevenin. So in this case, everything there has been shorted out so that we have our Thevenin equal to R1 and R2 in parallel with R2 and R3 and R4 in parallel added together in series, because we could take that and stretch it all the way out. So our equivalent circuit then, like we've seen before, our Thevenins would equal or would be the same as the circuits, just like we've already seen. Okay, so here's a little example here. Determine the voltage and current for the load resistor and the bridge circuit. So if you just follow the procedures here, use those values, you will be able to determine those values. The answer comes out to the Thevenin's equivalent for the bridge is R Thevenin 529 ohms, V Thevenin 5.32 volts. So in determining the equivalency by measurement, again, you would remove any load. You could put a voltmeter on the output and measure the V Thevenin. Connect a variable load resistor, set its maximum value across the terminals here. Adjust our load until the V load is 5/10 of V Thevenin. When V of the load is 5/10 V Thevenin, our load is then R Thevenin. Remove the load and measure its resistance to get R Thevenin. This is just a way of if you wanted to do it by actually making measurements. So what are the two components of a Thevenin equivalent circuit? Well, they are the Thevenin equivalent, C's for V Thevenin and R Thevenin. The general form, as we've seen, every time we've gone through the entire process, this is what we end up with, V Thevenin, R Thevenin. How is V Thevenin defined? It's the output circuit voltage between the two terminals in a circuit. How is R Thevenin defined? R Thevenin is the resistance as viewed from the two terminals in a circuit with all the sources replaced with their internal resistances. So if we draw the Thevenin equivalent circuit as viewed by the R load here, if we went through and solved this circuit, we would end up with 22.7 ohms, 22.7 ohms, and 25.8 just by following the procedures. Go ahead and do that. The other side of a Thevenin's is something called a Norton's theorem. Norton's theorem uses current sources instead of voltage sources. So there is your form for a Norton's equivalent circuit. When we come back, we'll look at Norton's.